Okay, question 4. Which of the following is an example of a function whose graph in the xy plane has no x-intercept? Okay, so we want a graph that had no x-intercept. The x-intercept where the graph crosses the x-axis. Okay, let's go through each one and see what we have. So A says a linear function whose rate of change is not zero. So the rate of change is just another word for the slope. Okay, so they're saying the slope is not zero. And think about the graph of a linear function, right? It goes on forever on both sides. It's a straight line. Okay, so the slope is not zero. It won't be a horizontal line. Okay, so it's not a horizontal line, no matter if you have a positive slope will be like that, right? It will cross the x-axis, or we can have like a negative slope like that. Again, it will have to cross the x-axis at some point because for a linear function, it goes on forever, right? So eventually you have to go through the x-axis, right? Because you can't just put a horizontal line. So A will have an x-intercept. Okay, so A is not the answer then. Okay, we're looking for something that does not have x-intercept. Okay, let's look at B. B says a quadratic function with real zeros. A quadratic function, if we think about the graph again, quadratic function will give us a parabola. And with real zeros, okay, so the zeros here is, okay, so sometimes they call it zero. You can also call it roots, right? Or solutions. These are all interchangeable, right? So that means for what x value makes the y value equal to zero. And graphically speaking, the zeros are going to be our x-intercept. Right, these are all interchangeable. So if we have real zeros, that means we have x-intercepts on the graph. Okay, so it could be like, something like this, right? It's probably, so it crosses the x-axis at some point. Okay, so it can either go through 2 point or at 1 point. Okay, if you have like, like this, it only touches 1 point, but it had to have a zero. So it has to have x-intercept. Okay, so it's not B. Well, C, if you look at C, it's actually the opposite, right? So it's kind of a quadratic function with no real zeros. On no zeros, we said the zeros are the x-intercept, right? If it doesn't have real zeros, then it has no x-intercept. So well, it had to be C then. Okay, so the zeros are another word for x-intercept. So no real zero, no x-intercept. And if you look at D, says a cubic polynomial is at least one real zero. Again, it has a real zero. So I had to go through the x-axis, right? So a cubic function is like a S-shaped graph, right? But again, if it goes through, it says have at least a zero, so I had to go through the x-axis. Okay, so not D. So for number 4, our answer should be C here.